Good evening to all. Thank you, Philip, for that kind and nice introduction. I don't know whether I deserve it or not. Anyway, thank you so much. Thank you, Kean committee members, President Sojimon James, Board of Trustees, RVP Biju Puducherry. Thank you all for inviting me. I want to let you know one thing, that I am not a good public speaker. I am not an orator or a fiery speaker like Philip. But I tried to copy something from him, but it never worked out. So I did the shortcut. What I do is that now I write a piece of paper, the note that I'm going to read. That is the easy way I can do. So Biju Puducherry told me to speak a little bit about my engineering experience in US. Before that, I just want to say a few words about me. I am originally from Tiruvalla, Kerala. Came to US in 1986. Married and living in New Hyde Park. I have 2 kids and 4 grandkids. So now, moving on, 1986. I started with CRS Serene as consultant engineering firm, and then I joined New York State DOT in 1989 as a JE. Like Philip was already told that, I became the engineer in charge for the Kaskiasko project. So that was one of the most interesting projects I ever did. Kaskiasko Bridge, so I like to speak a little bit about Kaskiasko Bridge project. That is my main intention today. So that is a cable stay bridge. As you all know, there are various types of bridges like suspension bridge, arch bridge, truss bridge, cable stay bridge. So cable stay bridge is a relatively new bridge design. Suspension bridges have 2 pylons or piers, and cable stay has only 1 pylon or pier. So this is the difference between a cable stay bridge and a suspension bridge. And this was a design-build project, and the total cost was about $900 million. So as you all know that most of the major projects we have right now is all design-build projects. The reason being design-build is, the procurement method is, they are using this design-build is because it is very fast, relatively fast. Usually a bridge design takes about 4 years, 3.5 to 4 years. And then the conventional method is design, bid and build. So we design it, then we give it for bidding, and whoever wins the bid, the contractor will build it. But here, the design and the construction will go concurrently. So that is the major time-saving factor here, the design build. So usually what they do is that for DOT they hired a consultant, WSP, to prepare the initial design and the scope. So they prepare the initial design and we give it to the contractor, design build team. So various team come and bid for the job. So what they do is that they give us they submit a concept plan, cost, CPM schedule, and the work experience of the company and the people who are leading the projects. So then all the design build team do their design presentation in front of the owner. Here it was State DOT. Then the DOT analyzed the design and they picked the best design build team suited for our need. Like I said, the good thing with the design build is it's a fast method. The design and construction go concurrently. So as the contractors start the work, the design part of the full, we give them only 30%. The rest, They start with that 30% and the rest they will do concurrently. They start the design and do the work simultaneously. So design build team includes the designer, contractor and a QC group, the quality control. So it is the responsibility of the design build team to do the quality control. And the owner, DOT, is responsible for quality assurance. So QC and QA. So QA, quality assurance, do only maybe 10-25% of the test. But the QC is supposed to do the 100% of the time. They have to do the check and the testing and everything for the steel and the concrete and asphalt and whatever. The DOT is supposed to be doing only a percentage, like 25% or 15% or something, like spot checking, whether the design build team is doing everything as per the spec. So I just want to give a brief description about the work. I hope you don't mind, and I'm not going to take much time for this. The first one was the demo portion, demolition. I don't know whether you all saw the old bridge. That was a truss bridge, very old, and the state was spending millions and millions of dollars every year to repair it and keep it safe. So during the demo, what they did is that they cut the whole bridge, and there was a barge waiting, in the river down, and they lowered the whole bridge into the barge and they carted it away. That took about a week, I think. That the process was very slow because the lowering part was very slow. It was going by inch by inch by inch because it's a huge structure. And the approach span was demolished by controlled explosion. They hired a specialty contractor from California. They used the explosive on each. It was about a half-mile long, this approach span. And they put the explosives, and by the turn of a switch, everything came down like in seconds. And then they cut away the whatever came down, all the various parts. So that was the demo part. The new construction of the pylon, the piers, the big pier. If you know that bridge, you can see two big piers. That's called the pylon. That pylon has the footing is 100 feet deep because they have to go all the way to the bedrock in the river. And then in that rock, they have to carve out 15 feet deep and 9-foot diameter hole. And that's where they put the rebars and the coffer dam and everything. That's how they start building the pylon. So it was 100 feet deep, 115 feet deep, and the height of the pylon was 200 feet. That's including the rock socket. And the approach has a pile foundation also. As you all know, most of us here are engineers, so you know that when we do a pile foundation, we have to do various testing, like static load test and dynamic load test. That's how you determine the blow count for the pile, how many blows you need on the pile. So only by doing the dynamic and static load test, you can calculate the blow count for the pile. And nowadays there are so many computer programs, you can come up with the blow count for the piles. The approach span. So we were talking about the main span, and the approach span was a continuous span with no joints. Most of you know that the biggest problem we face on the bridge is the deterioration of the bearings. And the bearings are all at the joints. So whenever the water and the salt and everything comes down, go to the steel and it gets deteriorated. So that was a major problem for all the bridges, steel bridges. So in order to rectify that problem, they come up with a continuous spans. So there is no joints in between. The expansion joints will be only at the end. So the expansion and contraction of the bridge will be taken care at the end of the bridge, end joint of the bridge. So this was a continuous span bridge with no joints. And the beams were precast beams, and the slabs were post-tensioned concrete slabs. So because it was precast slabs, it was very easy. Once they put all the steel and everything is ready, they bring the precast panels and they set it up on the stringer, and all these panels are joined with high density concrete. So that was very fast. That part was very, very fast. And the superstructure erection was a method called balanced cantilever method. So what they do is that they connect the stringers on the pylon. This is the pylon, they go on both sides with the stringer, and once the stringer is done, one stringer is done, they pull the cable from the pylon, and the cable is attached to the stringer. And the next one, they go simultaneously on both sides together until they reach the other side of the river. So that's called a balanced cantilever method of erection. The deck was constructed using precast panels, I already told you that. And the other interesting design in this bridge, some of the bridges on the approach spans were called integral abutment bridges. That's also a relatively new design. So again, this bridge doesn't have any joints. But if you ask me how the expansion and contraction will happen, because at the end of the bridge they put a approach slab, and underneath that they put a sleeper slab. So this approach slab will slide on the sleeper slab. So when any expansion or contraction is taken care of by this the sleeper slab. So those are the few things I just want to mention about this new bridge and the new method of construction we had. Basically, this is what I just want. This was one of my exciting experience in my engineering career, and I just wanted to share it with you guys. And if you have any questions, you can ask me. If I know the answer, I will answer it. Otherwise, lot of this press conference, they say that I will get back to you with the answer. All right? Okay, so again, thank you for inviting me for this program. And it's a great honor and privilege to be here and do this short presentation. Thank you very much. God bless you.
Thank you, keynote speakers, for your heartwarming and personal messages. Now, may we welcome ex-Kean BOT Chair, Mr. KJ Gregory, for the plaque presentation.
It was a great pleasure and an honor to present this plaque to our friend George. We will work together not in the engineering field, but in a Kean field. He was our secretary and other various positions took that things. Without any delay, I would like to read this plaque. It says that Kerala Engineering Graduate Association of Northeast America, Kean, presented to Thomas M. George, P.E., with a deep appreciation for being the chief guest and keynote speaker of Kean's Long Island Regional Meeting, May 4, 2024. Thank you.
There is another surprise citation for Mr. Thomas George from Office of the County Executive, Nassau County, which he doesn't know. So it's too long to read, but I may be reading. Whereas the County of Nassau is proud to recognize those outstanding individuals who render significant contributions for the enhancement of our region and the betterment of our residents. And whereas Thomas George is such an individual, and you, Thomas George, Nassau County Public Works Deputy Commissioner, have worked diligently on behalf of causes and ideas which uphold the principles of human decency. And through the years, you have demonstrated a selfless commitment to the County of Nassau and its residents that warrants attention and gratitude. And whereas the County of Nassau is proud to extend the commendation to you, Thomas George, as you are honored by the Association of Kerala Engineers, Association of North America, and for your spirited leadership, dedication, and service to the community. Now, therefore, I, Bruce Blackman, Nassau County Executive, on the 4th day of May 2024, do hereby present this citation to Thomas George on behalf of Biju. Please come.